Chapter 4. I'm Mrs. Jordan, and you might wonder why I'm dressed like this. It is because this is a hula skirt made by my cousin, and we are going to mix it up a little bit. Chapter 4, Section 1, Question 1. You're going to plug in each of these ordered triples and see if it works. Now, we have dealt with ordered pairs, which have x's and y's, and then this one has x's, y's, and z's. If you've ever seen our coordinate plane, we usually have our x-axis and our y-axis. And if you were to have our z-axis, there's something called the right-hand rule. You have your fingers pointed toward the x-axis, you curl them toward the y-axis, and your thumb shows that the positive z-axis is coming straight out of the board. We are not going to be graphing these. We're just going to see, does it work? So we're going to plug work and answer. So we have 2 times x plus 3 times y minus z, which we are plugging in, equals -7. We're plugging it in, we're plugging it in, we're plugging it in. Order of operations, 8 minus 9 minus 6 equals -7. 8 minus 9 is -1 minus 6 is -7 is equal to -7. Hey, it works! But that's not all. We only plug this into the first equation. There are 3 equations. There are 3 numbers. We have to plug them into all of them. So there's the first time I plugged it in. And then it says x plus 2y minus 3z equals -8. So 4 is here, -3 and 6. Order of operations, multiplication. And then -2 minus 8 is -20 equals -8. Already we know that this is not going to work. But unfortunately, it says to plug it in. We're going to keep going. So sorry. 4 times x minus y, leaving a blank there, plus 2 times z equals 18. Plugging in our 4, plugging in our -3, and plugging in our 6. Order of operations, we have 16 plus 3 plus 12 equals 18. Left to right, 19 plus 12, double checking 19 plus 12 is 31. And hey, it still doesn't work. So this one works, but this one doesn't, and this one doesn't. And so we're supposed to say, does it work or not? Yes or no? No, it does not. But take a look. Plug, work, answer, plug, work, answer, plug, work, answer, yes or no. Gosh, 10 things for that side. Then we have to get to this one. So this was still 2 times x plus 3 times y minus z equals -7. Plugging in our new point, order of operations, -6 minus 1 is -7. Hey, it works, but wait, there's more. We need to plug it into the next one. X plus 2 times y minus 3 times z equals -8. Plugging in 3, -4, and 1. Order of operations, -8. Multiplication. And we get 3 minus 8 is -5, minus 3 is -8. Ooh, it's looking good so far. This one might work. And then 4 times x minus y plus 2 times z equals 18. Plugging in our x, y, and z numbers, order of operations, 12 plus 4 plus 2, 16 plus 2 is 18, so we get 18 equals 18, and gosh, we will get yes. I don't know where the yes and no for this side went. All right, I'll put yes there. Chapter 4, Section 1, Question 2, Notes. A former student made this for me, but unfortunately, I forgot what his name was. So, if you are that student, please tell me. All right, so consistent, inconsistent, and dependent are the vocabulary words for this section. And what we've done is to get to consistent, inconsistent, and dependent, We've actually made a chart of all the different things that could happen. So if we take a look, we could have the same line twice, two lines right on top of each other. And if you have the same line, the slopes will be the same. The y-intercepts will be the same. They will have infinitely many solutions from back in chapter 2 and chapter 3. We will have the same line because they intersect an infinite number of times, and they will be called dependent. Now, if you look, in red it says consistent and dependent. Consistent meaning it has an answer. In fact, it has infinitely many solutions. Dependent meaning that they depend on each other, meaning if I was to change one, I would have to change the other because it's the same line. Now, this is for a future class. This is for our class. We are calling these dependent lines. Then, we could also have parallel lines. So with parallel lines, they are called parallel, the slopes would be the same. We had that back in chapter 3. The y-intercepts would have to be different. That's what keeps them apart from each other. They are no solution from back in chapter 2 and chapter 3, and they are called inconsistent because consistent means it has an answer, and the parallel lines do not intersect, so it doesn't have an answer. That's why it's called inconsistent. Last but not least, we have intersecting lines. So intersecting lines are lines that cross, and their slopes would have to be different. If they were the same, they would be one of these cases. So as soon as the slopes are different, they are going to be intersecting lines. Their y-intercepts could be different, or they could be the same. Nobody cares. Yay! And then they will have one solution where they cross over each other, and having that one solution is why it's called consistent. Consistent meaning that it's an answer. You'll see that a future vocabulary word is independent because I could change one line and I would still only have one answer. I could change the other line. I could still only have one answer. They're not depending on each other. We're going to get into what this looks like in our section very soon. Chapter 4, Section 1, Question 2. Again, we're using the vocabulary for the last slide. Dependent is the same line twice. Inconsistent is for parallel lines that have the same slope but different y-intercepts, and consistent are for lines that have different slopes and will therefore cross. Write the equations in slope-intercept form and show work. We have been solving things for slope-intercept form in chapter 2 and chapter 3, so hopefully you have that down by now. Now, if you look, one of these is in standard form, x is y's equals number, and one of them is already in slope-intercept form. That is because I'm being lazy. I just want us to solve that one. And you'll notice that all three of these are the same. That way, we can really get into the vocabulary, not as much getting into how to solve this. But as a review from chapter 2, solving this for y. You'll notice that this is my favorite standard equation with x's and y's equals numbers. We get y equals negative 2/3 x plus 2. So if this is y equals 2/3 x plus 2, and this is y equals 2/3, oh, wait, this one is negative 2/3 x plus 2. Those are exactly the same. They are the exact same lines, their slopes are the same, their y-intercepts are the same. This is dependent. Here, y equals mx plus b, our slopes are the same, our y-intercepts are different. This is inconsistent. The slopes are different. That's a negative 2/3, and this is a positive 2/3. But we are trying to trick you, so be careful about that. They're very similar to each other. But even if it was perpendicular to each other, as long as the slopes are different, this is consistent. Chapter 4, Section 1, Question 3. Solving systems of equations by elimination. Systems of equations are more than one equation. You'll remember back in question 1 we had 3 equations. Now we have two equations. We have our x's and our y's. We're going to solve them for both x and y. In chapter 2, we were just solving for x. Now we're solving for x and y. Very soon, we'll be solving for x, y, and z. All right. Elimination. Elimination is, of the two methods of solving these problems, the most powerful because it's the way that we're probably going to be solving the three variable equations as we go further in math. So in order to eliminate something, we need to see which letter we can eliminate first. Now, technically it doesn't matter, but if you look at 2 and 3, what is the least common multiple of 2 and 3? You could keep multiplying them until they equal each other. They would equal each other at 6. Where do 2 and 5 equal each other? We could multiply them until they equal each other at 10. I don't know about you, but 6 is smaller than 10, which would give me smaller numbers. That's going to be a little bit easier. So to make this into a 6, I need to multiply everything by 3. Multiply everything by 3. Multiply everything by 3. And that, coming across here, will make a 6x plus 15y equals 78. Here, to make a 6 here, I'll have to multiply everything by 2. And that will give me a 6x plus 4y equals 34. Now you might notice that I can't eliminate anything because a 6 plus 6 is 12. What I would need to do is change one of those signs. So here, would I rather have 15y minus 4y or 4y minus 15y? I'd rather have the bigger number be positive and the smaller number be negative. So I would actually have negatives down here, which means technically I multiplied everything by -2. It's easier to check after you've multiplied to make sure that you're going to get a positive on the variable side. Do you have to? No, because math works. 6x minus 6x is 0x. They will cancel. 15y plus a -4y gives you 11y. And 78 minus 34 gives me 44. We divide on both sides, and you'll find that at this level of math, they usually come out fairly nicely. Oh, wait, we're not done yet. That's not the answer. We don't want to box that. We've only found y. We also need to find x. Now, I don't want to plug into these problems because we just multiplied them to make them bigger. We want to go back to one of our original problems. They're both all positives. This one I feel like has slightly smaller numbers. So I'm going to plug into this. 3x plus 2 times y equals 17. I'm going to solve this for x. Hey, it's coming out nicely again. How nice. So here we're going to make something cancel. We're going to add and solve and plug and solve and write the answer. How do you write your answer? We have to find an x and a y, and the way we write that is x first, y second. Now be very careful about this because some students remember that they found the 4 first and then they found the 3 second. So they write 4 comma 3 instead of 3 comma 4. Look, we have another one. We're going to make something cancel. 2 and 4 will meet up at 4. 3 and 6 will meet up at 6. We're going to go for the 4 because it is smaller, and we're going to do that by multiplying everything here by 2. And to make this into a 4, it's already a 4. How wonderful. I only have to multiply one of them. If you can get a situation where you only have to multiply one equation, less chances for mistakes. So that is wonderful. 4x minus 6y equals 18. And we're bringing this one over so that they stack nicely on top of each other. And we notice that that's odd. I just wrote the same thing twice. We are going to want something to cancel, so we're going to change the signs on one of them. In this case, because of the exact same things, it doesn't matter. I can do this one, or I can multiply all these by -1, change these signs. Notice I'm doing it in a different color, so I make sure I do it to every single term. Bar, and adding. This side is 0, and this side is 0. You might remember this from back in chapter 2. If you get a number equals itself, this is infinitely many solutions. Now, I do need to see the work all the way till here. And I also need to see the actual answer. Same as in chapter 2, where we had to continue on until you got a number equals a number before you could say this answer. It is also of type identity, but that's not part of your answer. We need to see the work to get a number equals a number. This is your answer. Chapter 4, section 1, question 4. Solving systems of equations using substitution instead of elimination. How do we know which to use? Well, with elimination, we had standard form x's, y's equals number on both equations. Here, for substitution, it tells us x is equal to something. Now, when we have a single variable and an equal sign, that tells us that substitution is probably the easier way to go. Now, some students say, I see a single variable and an equal sign, but it has this other stuff by it. So that has an x equals, and this has a y equals. That's what tells us we're going to be using substitution. Here we go. We're going to substitute, meaning plug it in. So 3 times x minus y equals 22. X is equal to y plus 12, so I'm going to just plug in y plus 12. This makes it into a chapter 2 question, where all we have to do is distributive property. Combine like terms. Our additive inverse. Multiplicative inverse, and we get y equals -7. But wait, we also have to find x. Well, technically you could plug into either of these. One of them is going to be easier. This is already solved for x. So we're going to get x is equal to y plus 12. And after we plug and solve, we still have to write our answer. X first and y second. Then we have our other one. We have 2x minus 3 times y equals 7. We're going to plug in y equals, so instead of y, we're going to write 2/3 x minus 2. Hey, distributive property, 2x. Negative times positive and negative. The 3 times 2 divided by 3, that's 6 divided by 3. That is 2x. Negative and negative is positive. 3 times 2 is 6 equals 7. A positive 2 and a negative 2, those cancel out, leaving us with 6 equals 7. But 6 does not equal 7. If it makes you happy to put a does not equal sign there, that's fine. But this is what I need to see, is a number equals a number. Then you remember back to chapter 2. When you have a number equals a different number, that is a no solution. There is nothing that will make the left side equal to the right side. So we have plug, work until you get number equals number, and then your answer. The answer is no solution. Chapter 4, section 2, question 5. Now you might think, we were just in chapter 4, section 1. Well, instead of spending an entire extra day on chapter 4, section 2, we're only spending this one question on it. And so it actually goes into the chapter 4, section 1 portion. This is a calculator only. Now, is there a way to solve this by hand? Yes. If you take a look in the lecture notes, it shows you how to solve it by hand, and it takes about a half a page. I'm going to show you how to solve it very quickly in the calculator. We also have a file about how to use the TI 83 or 84 calculator to solve this using something called matrices. This is an amazing skill because you are going to see systems of equations on your SATs, your ACTs, your AccuPlacers. And if you know how to use it on a calculator and solve the answers, it'll be very, very fast. So the matrix is on the left-hand side, just below math. Mine is written in blue, so I have to hit second and matrix. Then there are three things. It says names, it says math, and then it says edit. The first thing we're going to do is edit, the second thing we'll use is math, and the third thing we'll use is names. So first we're going to use the arrow keys here to go to edit and hit enter on matrix A, which is the first line. And then it says 1x1. This is one of the few places that we use an x for multiplication in algebra. You'll remember the other time is in chapter 1, section 6, scientific notation is the other time we use an x for times. And what we're going to do is we're going to be putting in all of the numbers here, not the letters. What we're going to be entering in are the coefficients 2, 3, -1, and -7. Remember, it has to be in order, just like in our standard form of an equation. 1, 2, -3, and -8. 4, -1, 2, and 18. This is what our matrix is going to look like. If you have an older calculator, like an 83 as opposed to the 84, this is an 84 plus CE for color. Mine is going to fit it all on the screen. The other ones, you'll have to move your screen over and it'll shift for you. Now, 1 by 1 will only let us put one number in. If I put a 2 enter, it'll make it go 2 this way. So the first number is your vertical and the second number is our horizontal, kind of like slope with rise over run. So I want to go back here and I want to put in 3 enter, 4 enter. It now gives me all 12 spots, and I'm going to put 2 enter, 3 enter, -1 enter, -7 enter. I have the entire first line over. Enter will shift me this way and then it'll kick me down to the second line. 1 enter, 2 enter, -3 enter, -8 enter, 4 enter, -1 enter, 2 enter, 18 enter. I have all of the numbers in my calculator. Now, if this was a test, I would double check that these numbers I typed in are the same as those numbers, because if you ever type them in incorrectly, the calculator will do exactly what you told it to. Now, this is what we had to do in edit. We're going to hit second and quit. Quit is right next to the second button above load. And from second quit, we're going to go into math. To get in there, we have to go second matrix. Some students press the math button. We need the math within the matrix. And so we go to matrix math and hit the up arrow key, because what we're looking for is double REF. That stands for reduced row echelon form, but nobody needs to know that. So we're going to go to double RF and hit enter. Then, third thing, we're going to go to matrix, second matrix, and the name of the matrix that we use is A. And we're going to make it say double RF A. It is polite to put it in parentheses. Hit enter, and it will tell us 1, 0, 0, 3, 0, 1, 0, -4, 0, 0, 1, 1. This says that the first answer is 3, the middle answer is -4, and the last answer is 1. So the answer to this is 3, -4, 1.